First, I set up a very simple system, which is a Unit 48 processor. Its Out1 and Out2 outputs are connected to the first and second channels of the power amplifier. The power amplifier is connected to a 10-inch full-range speaker and a 15-inch subwoofer. Next, the first input channel of the processor is connected to the measurement sound card. Next, open the VOS4 software and the Unit 48 control software. Right-click on the Unit 48 control software side and reset the data to start over. Input A is connected to the output of the sound card, and Out1 and Out2 are connected to the full range and subwoofer respectively. Create a route for input A, routing it to 1 and 2. Now, click S on Out1 to measure this channel alone and mute the other channels. Open the VOS software and click Play. Next, turn up the volume of the sound card, insert delay, and then save. This is frequency response 1. Pause. Next, you can see a frequency response 1 in the Out1 channel, and you can also see the curve of frequency response 1 in other channels. This means that the VOS data has been uploaded to the interface of the Unit 48 processor. Of course, you can also click Automatic Measurement directly in the Out1 channel. It will automatically turn on solo to ensure that only the sound of this channel is measured, and other channels will not be turned on. After the measurement, solo is automatically released. This is the curve measured by this channel. Now select the frequency range and click Automatic EQ. Before clicking Automatic EQ, you can see a row of automatic here. That is, you can choose the number of EQs to be automatically processed, up to 12 points. Of course, you usually don't need so many, so you can remove some. Now click Automatic EQ to see the calculation result. The dark blue one is the result after processing, the light blue one is the result before processing, and the green curve is the target curve. You can select the type of target curve here, or you can make a target curve yourself. The following EQs can be checked individually by bypass. In fact, the first one has no effect because its gain is 0 and can be removed. The second one can be seen to have an effect. The third one is OK. The next one is also OK. Then click Next. Checking the frequency is actually unnecessary because it is already very low frequency and there is no need to reduce it further. The next one can be kept, or you can adjust it manually. For example, the low frequency can actually be increased a little. So at this frequency, you can increase the Q value and set it to 5 decibels. Next, light up bypass and add it up. You can find changes. The Q value is 5 and it can also be seen that it is OK. Increase the frequency slightly, say to 170, and see if it feels better. Add a low frequency to protect the low frequency, because the bass has been increased a bit. Next, go back to the VOS software to measure again and see the result. Of course, you can also perform automatic measurement in the current software, which is faster. It can be found that the result this time is exactly the same as the previous calculation result. Now, without looking at the result or the target, only keep the imported curve. You can see that it is the same as the VOS software. Next, measure the subwoofer. Double-click Out2 and then click Solo. Next, open the VOS software and click Play to get the curve of the subwoofer. There is no crossover. Now add the crossover. The subwoofer is turned down from 40 Hz to 100 Hz, all using Butterworth 24 decibels. Let's see the result. Measuring again is also OK. The sound pressure level of the subwoofer may be slightly lower, so you can reduce the full range a bit. For example, reduce it by 6 decibels. Reduce the gain of the full range Out1 by 6 decibels. Go back to the VOS software. Next, reduce the curve by 6 decibels, so there is no need to measure again. It can be found that its phase is slightly misaligned. Try adding 1 millisecond. Adding 1 millisecond seems too much. Let's use 0.5 milliseconds. 0.5 milliseconds should be about right. Now go back to the processor software. Add 0.5 milliseconds to the full range. Don't mix up the channels, and then turn on mute. Now measure the two channels together to see what the overall curve will be like. Save it. Next, you can listen to the sound to see if it is correct. If not, it can be modified. Thank you for watching. See you next time.